Supersonic flight in essence refers to flights that travel at speeds greater than the speed of sound. The first flight to have achieved this feat was NASA's X-1 aircraft, the first in line in the institution's tradition of X-planes. Currently, commercial planes are not allowed to fly at supersonic speeds over land. This is because in doing so, they would end up generating sonic booms, extremely loud and disruptive sound created by shock waves that are in turn made by objects traveling at supersonic speeds. Now, 75 years after the X-plane series was started, NASA commissioned and Lockheed Martin developed X-59 KSST, or Quiet Supersonic Technology, is aiming to break the sound barrier a lot more quietly by reducing the sonic boom to an acceptable level. The U.S. aerospace giant Lockheed claims that the X-59 structure would greatly lower the decibel level of a sonic boom reaching the ground. The plane will be flown as part of a mission whose aim is to collect data on quiet supersonic flight and gauge public reactions to supersonic thumps. First generation X-1. 75 years ago, a sonic boom thundered for the first time over the high desert of California. A small group of researchers from NASA's predecessor organization were the first to hear the thunder crack coming from the Bell X-1 rocket plane flying faster than the speed of sound. It was October 14, 1947, and the joint X-1 team of NACA, U.S. Air Force, and Bell engineers and pilots had broken the sound barrier, an imaginary wall in the sky some said was impossible to penetrate. The X-1 was a bullet-shaped airplane that was built by the Bell Aircraft Company for the U.S. Air Force and the National Advisory Committee for Aeronautics, NACA. The mission of the X-1 was to investigate the transonic speed range, speeds from just below to just above the speed of sound, and, if possible, to break the sound barrier. The XS-1 program not only proved that humans could go beyond the speed of sound, it reinforced the understanding that technological barriers could be overcome. Many structural and aerodynamic advances were pioneered by the original XS-1s, including extremely thin, yet exceptionally strong wing sections, supersonic fuselage configurations, control system requirements, powerplant compatibility, and cockpit environment. For the first time in a transonic-capable aircraft, an all-moving stabilizer was utilized. The flights of the XS-1S opened up a new era in aviation. Silent supersonic technology. The X-59 KSST is an experimental aircraft that is being developed by Lockheed Martin for the U.S. Space Agency NASA. The project, aimed at developing a quiet supersonic plane, has made major strides since its contract was handed over to Lockheed Martin in 2016. The demonstrator model that the firm has created is a single-engine aircraft that measures 28.7 meters lengthwise and has a 9-meter wingspan. The aircraft has an elongated nose designed to lower sound levels. This experimental aircraft is powered by an F414 GE100 turbofan engine specially designed for installation on the X-59. They were supplied to NASA last year. In February 2016, NASA awarded Skunk Works, a Lockheed Martin branch, a contract for a preliminary design of the X-59, worth $247.5 million. The target was to pre-design the plane by 2020 and deliver it by 2021. In April 2018, Skunk Works was selected for the design, build, and flight test of the X-59, and in November that year, the manufacturing of the first parts to be put on the X-59 began. In June 2019, the study results and concept for the quiet supersonic passenger airplane were revealed. In a major development in September that year, NASA and Skunk Works completed the critical design review for the X-59. The team has continued to make significant progress on this experimental airplane's assembly. Sonic boom. The ground noise is expected to be around 60 dB, about 1/1000 as loud as current supersonic aircraft. This is achieved by using a long, narrow airframe and canards to keep the shock waves from coalescing. It should create a 75 perceived level decibel (PLDB) thump on ground, as loud as closing a car door, compared with 105 to 110 PLDB for the Concorde. The central engine has a top-mounted intake for low boom, but inlet flow distortion due to vortices is a concern. The flush cockpit means that the long and pointed nose cone will obstruct all forward vision. The X-59 will use an Enhanced Flight Vision System, EVS, consisting of a forward 4K camera with a 33 degrees by 19 degrees angle of view, which will compensate for the lack of forward visibility. United Technologies subsidiary Collins Aerospace was selected to supply its ProLine Fusion cockpit avionics, displaying the boom on the ground, and EVS with long-wave infrared sensors. The Collins EVS 3600 multispectral imaging system, beneath the nose, is used for landing, while the NASA External Vision System, or XVS, in front of the cockpit, is giving a forward view. Test success. Along the way, researchers gained a greater understanding of how aircraft create sonic booms and turned their attention to the idea of lowering the intensity of the sonic booms by manipulating the shape of the airplane. That idea was tested in flight by NASA's Shaped Sonic Boom demonstration program during 2003 to 2004. It used a Northrop F-5E jet whose fuselage was modified to give it a shape designed to produce quieter sonic booms. With the X-59 and its quiet supersonic technology building on all that has been learned since the X-1 first proved it was possible to go beyond Mach 1. NASA hopes to enable industry to make faster-than-sound flight available to everyone. We've kind of been stuck with our airliners at about Mach 8 for the past almost 50 years. So being able to get there, wherever there is, much faster is still kind of an unfulfilled dream, said Peter Cohn, NASA's Mission Integration Manager for Quest. There's an old joke about how the X-1 broke the sound barrier and NASA has been trying to fix it ever since. Cohn doesn't see it that way. Instead, the new obstacle to supersonic flight is the speed limit due to the negative effect of sonic boom noise. He said, with the X-59 flying on the Quest mission, I think we're ready to break the sound barrier once again. Cohn said, first flight of the X-59 is targeted for early 2023. Thank you for watching my video. Please like and subscribe to our top defense news channels to find more exciting content, and don't forget to hit the bell icon to be notified of our newest videos. Stay tuned.